Hello class, for today we're going to go over inverse trig functions. We're going to finally take a break from graphing trigonometric functions. We've been doing them for a long time and I understand, and I'm going to teach you guys for today how to read the inverse trig functions, like they are 1 over this number, and how to evaluate values at a given quadrant. Now from the beginning, the notes that you guys should be taking are these three, which states that cosecant, secant, and cotangent is simply 1 over sine, 1 over cosine, and 1 over tangent. So um, the way that I always remember it is that if you have a trig value that is sine, that it starts with s, then your inverse trig function should start with c. It says cosecant, and this is called the cosecant of x, of t. This is called secant, and this is called cotangent. Cotangent is easy to remember because if it's tangent, then it's cotangent, right? But for these two, it could be a little bit confusing. Then remember that sine is cosecant and cosine is secant. So c is to s and s is to c. So they have to, like, the letters have to swap the first letter. Okay, so those are the ones that's being associated with. Now, for homework questions, you'll be dealing with questions like these. So, for example, given the sine of theta is equal to 3 over 5 and the angle theta lies in quadrant 2. So, if I were to draw the grid, quadrant 2 would be 1, 2, 3, 4, which is this one. And also remember, right, ASTC, we're going way back in March/April area where I've been teaching you how to evaluate trig functions at a different quadrants. Now here, they tell you that theta is, a sine of theta is 3 over 5. So this is your opposite and this is your adjacent. This is your hypotenuse, I'm sorry. Now, for all of these questions, you'll be given two freebies, which is sine of theta is 3/5. That would mean that cosecant of theta would be 5 over 3. You just have to swap up the numbers, because if you were to do 1 over sine of theta, that means it's 1 over 3 over 5. That's 1 divided by 3/5, which is the same thing as saying keep, change, flip. So it becomes 5 over 3. Now, cosine of theta and tangent of theta, they all should have negative numbers because you're in the second quadrant and only sine is positive. Now, for cosine and tangent, you need what we call reference angle. We need a triangle. If it's in the second quadrant, okay, it should be this terminal side where this is your reference angle because it's the angle that is formed with the x-axis. And if I were to draw a line straight down, what we get is that this is your opposite length of 3 and this is your hypotenuse length of 5. So with this new right triangle that you see right here, you can use that to figure out your adjacent side, which is 4, because you can use your Pythagorean theorem that says 5 squared equals a squared plus b squared, and then you can use that to solve for b. Now, once you have your adjacent side, everything's a piece of cake, right? Cosine is adjacent over hypotenuse, so 4 over 5, but it's negative. Secant, therefore, would be 5 over 4. Remember, it's just a reciprocal of it. You just have to remember that. That's all you have to do. Tangent, on the other hand, is 3 over 4 because it's opposite over adjacent. Then the cotangent will be negative 4 over 3. Okay? These will be the 6 trig values in which you'll be asked to evaluate. Don't worry, you will not be asked to find anything more than that. This is to the extent of how many trig functions there will be. Let's try this question on your own. Then that will conclude the video for today. Given the tangent of theta is equal to square root of 3, the tangent theta lies in quadrant 3. Okay, so your answer here, you should start with that. This is square root of 3. And cotangent is simply the reciprocal of it. So that means that it's 1 over square root of 3. Now remember, guys, if you remember, square root of any number in the denominator can't happen. So you have to rationalize it. So you get square root of 3 over 3 as your final answer for cotangent. Now you remember, you're in quadrant 3. Again, draw your grid, ASTC. This is quadrant 3. If it's quadrant 3, all of these values should be negative, all the rest of them. Then if I were to draw a terminal side here, this would be a reference angle in which tangent of theta is square root of 3 over 1, just to indicate how it's opposite over adjacent. So if I am using square root of 3 as my new value that's opposite from this angle, I will have to really draw myself a new triangle here that draw a line straight down like this. This is the right triangle that we're speaking of. So if that's the theta, opposite length would be here and adjacent length would be here. So I'm going to label it accordingly. Using these two lengths, can I use that to solve for the hypotenuse? Yes, you can. Square root of 3 squared plus 1 squared equals c squared. 3 plus 1 is equal to c squared. So c squared equals 4. So c has to be 2. It's pretty much the same thing as saying 30, 60, 90 degrees triangle if you haven't noticed. So 2 is hypotenuse. Then all you got to do is just write down the answers accordingly. So opposite over hypotenuse would be sine, so square root of 3 over 2. This should be 2 square root of 3. Rationalize it by multiplying both sides by square root, both top and bottom by square root of 3. You get negative 2 square root of 3 over 3. Cosine is 1 over 2. Then this would be 2. And voila, I'm done. Those are my 6 trig functions. Okay. Hopefully this video helped. Finish 2 questions dealing with the inverse trig functions like this. And I'll see you next time. Take care. Bye-bye.